Okay, so today we're going to be talking about Fourier series and Fourier transforms. A Fourier transform is representing a function as sines and cosines. So let's start off with the basics. A Fourier series is, so if you have an arbitrary sine wave, then if you know that it's a sine wave, all you have to know about the sine wave is its amplitude, which is 1, and its phase angle, which in this case is 0. So as long as you know the amplitude and the phase angle, you'll be able to draw the graph of the sine wave. So now, knowing this, we know that the Fourier series, the coefficients, as long as you know the coefficients and you know the phase angle, you'll be able to determine the wave. Okay, so now this can be represented as the following. So from real space, which is just what you see in the real, which is like an image of something, if you just take directly like an image using electron microscopy, you could transform this into reciprocal space. And reciprocal space is something like a diffraction pattern. And the way you do this is that this is ft, and here you can go back, you take the inverse Fourier transform. So now if you represent this as on a diagram, say we just have an image of a happy girl. And this is just background info, background noise. Okay, so here we could define the high resolution information as just her kind of facial features, her eyes, her mouth, her head, her hair, and the low resolution info would be this kind of background noise. Say delete all of the low resolution info, and we only took the Fourier transform of the image minus this background noise, you would get something like this. As you can see, the high resolution info, such as her hair, her eyes, her mouth, it's all kept, but instead of this kind of color, or this, I'm just drew this as representing color, you would get kind of a distorted version of the background noise, which could possibly even be like a slightly different shade or color. And one more thing is that because this is reciprocal space and this is real space, so this is an image and this is just what we would call a diffraction pattern. So another thing to note is that this is called reciprocal space because at each point, the reciprocal wavelength is measured. So that means that although you would expect your high resolution info to be near the center, the high resolution info is actually out here, while the low resolution info is here. So that means that although you expect, if you had a resolution of like 1 angstrom, you'd expect to be close to the origin, it's actually going to be farther. So now let's represent this graphically. So you can take like the Fourier transform of something like a step function. It would probably be some sort of wave represented like that. But this is relatively simple. If we want to take the Fourier transform of, say, a delta function, just 1p, it would be much more complicated because you would need multiple waves. You would need some waves undergoing constructive interference, some undergoing destructive, because you need to, something like that. So it would be a gathering of multiple waves. So yeah, that's it for Fourier series and transforms.